Welcome to our presentation. I am Ethan, and our group is going to present to you the customer churn prediction in over-the-top platforms. Over-the-top platforms stands for platforms such as Netflix, Spotify, and etc. So here's our agenda today. We're going to first provide an overview of our business problem, the solution approach, and the challenges within the implementations, our data architecture, an overview of our data set that we used, the actual implementation and detailed steps, and finally, the business value and future adoptions. So over-the-top platforms are accelerated by this pandemic with our digital adoption. And as platforms are growing, customers usually have multiple subscriptions. However, the cycle of each subscription is usually short, which is monthly. And this leads to a customer churn problem that there are a 44% churn in OTT industry in the US.
A typical customer journey starts from customer acquisition. Some customers will like the product if they have a positive experience or are offered favorable pricing. However, some customers will interact with this service less as time goes on because they are become fatigued or facing price pressure or attracted by other products. Specifically, we can identify churn customers by analyzing their behavior data for the OTT media in the service industry. For example, potential churn customers are less likely to add friends, click like, add content to their playlist, and so on. Thus, our solution is deploying a machine learning model on big data architecture to predict which customer will quit using the app. If we can forecast these customers before they leave, then we can reach out to them and promote some campaigns or discounts so that we'll not lose them. We know that acquiring a new customers can cost 5 times than retaining an existing customer. So this will make a company more profitable.
So now that we know that identifying customers who are about to churn is key to prevent that, let us find out what are the challenges associated with that. One of the main challenges is that the data is in mixed formats. Also, the data is really large. We have millions of subscribers across our platforms worldwide, and they have hundreds of data points across the subscribers, like what movies have they watched, how many times they watched it for, what is the timestamp of the movies, etc. Also, the data is coming at high velocity. It's being updated almost real time, and we need our machine learning models to also predict churn in real time to help us prevent that. These problems can be solved by leveraging big data. So we know that big data allows us to work with different formats of data. It allows for faster processing by parallel processing. That we can also have technologies that are compatible with fast streaming data. And we have, of course, reliable data lakes to store all the large data. So the architecture of our approach is as follows. The user data is being generated on these platforms, Spotify, Netflix, whatnot. All of those are then, the data is being stored on Amazon S3, which is our data lake. From there, we are taking the data to Databricks, where we are doing initial pre-processing of the data. Then on Databricks itself, we are employing Spark MLlib to build models to predict customer churn. Then those insights of customer churn along with customer features are then passed on to Amazon QuickSight, which is where we are visualizing our data and creating a dashboard. This dashboard is then being used by the sales team or the marketing team to reach out to the customers and have those interventions that prevent churn. To actually use this idea, we have also had a fictitious data set, a Sparkify data set on which we have implemented these methods. It's a music service similar to Spotify, and our goal was to actually predict customer churn and then help prevent it. So the data is at event level, which are aggregating to the user level. It's a large data set, about 12 gigabytes of data. It's also, we have tried to simulate streaming of that data so that we can understand if our tools are robust enough to deal with that. Also, we have the logs of user activity, demographics, and other such details.
Here we can define our process of the project into 3 parts. The first part is the data preprocessing. After we obtain our data set, we deal with the missing value and the outliers. And because in our data set, a user may have several events, and each event was represented by a row. So we aggregate our data set from the event level to the user level. And the next part is the feature engineering. During this part, we created several columns. In the demography features, we created columns such as state by extracting the state abbreviation from the original address. And in the transactional features, we create a column called the number of the day a user used our services ever since their registration. And we also create target variables to define whether a customer is churned or not. And the way we define customer churn is to check whether there is an event called cancel confirmation inside a user. And the last part is the model creation. We use logistic regression and random forest to train our model. And the model accuracy is roughly about 70%. So finally, we generated two outcomes. The one is that we use Spark streaming to perform the real-time analysis and the visualization on the stream data. The other one is that we use AWS QuickSight to create a dashboard to present the churn analysis.
Having discussed our solution approach in the previous section, next we'd like to talk a little bit more about how our solution can be implemented in situations where we have streaming data. Streaming data refers to data which is in motion, basically data which is being updated periodically, and we'd like to be able to use our solution on this sort of dynamic data. So in order to demonstrate this, what I've done is within PySpark, I've created 10 different sample files, and I've set it up in such a way that each of these files will get uploaded into our analysis in one by one, and our analysis will automatically show us the updated results without having to re-upload new sets of data every time. So the analysis that I've defined is that we are going to use our customer churn model that we've developed. We'll run it on the streaming data, and we basically try to understand what is the customer churn rate as predicted by our model across different states, right? Once I've defined this, I just have to start the stream so that the data starts flowing in. Then I can start querying the streaming data. So at the very beginning, we get some results from the stream. So we get the customer churn rate for 3 different states right now. But as more and more data starts streaming in, this analysis has to automatically update by itself without having to rerun any previous chunks of code. So let me just run this again. So as we see here, the chart has updated, which means that we have customer churn rate for more states right now. So the idea with this approach is that we can use this sort of streaming technology to develop dynamic dashboards that update themselves automatically. This might be crucial in situations where we have to monitor crucial metrics like customer churn in real time. So this is one of our implementations. So we have another implementation of our solution, and Yufan from our team will discuss more about that.
We did some churn analysis using AWS QuickSight. And the first part is about our most important KPI, which is count of total churn customers and its daily and monthly change. And the second part is churn analysis across different dimensions, such as gender, downgrade condition, subscription type, state, and agent dimensions. And the third part is churn analysis across different measures, such as register days, average session time, and average daily songs. And it is an interactive dashboard. So if you put your cursor on the plot, you can get more information from it.
We now look at the business impact of customer churn. First, predicting customers with higher probability of churn would help customer engagement teams to focus more efficiently. Second, the predictions could help reduce customer attrition through providing special incentives to target customers. Third, analyzing customer data can also lead to better customization content displayed on user profiles. Fourth, this would help identify common attributes of customers about to leave, and the business can work on eliminating them. Fifth, the analysis can be visualized into dashboards and shared with multiple teams for better synchronization. Finally, it always costs less to retain existing customers than acquiring new ones. Let us now look into OTT platforms who have already adopted churn management strategies. These are some of the top OTT platforms in the market: Amazon Music, Spotify, Hulu, Netflix, and Disney Hotstar Plus. Thank you.